Hello everyone, welcome to a new video. Now today when I was driving home on the train from where I study to visit my parents, I had a little look at maybe I can record a video. So this one came up here from DC Force, and apparently orbits are impossible. Well, it's more or less the way that the orbits are right now are impossible, which of course is something a bit different, but you know, let's have a look.
Hi there. Today I want to talk to you guys about orbits.
I already love the fact that the video is in 16:9, but like cropped so that it fits on a phone screen. But on a phone screen, it's like not the upright format, but rather it's.
NASA claims that our universe was.
I should maybe. Well, no, I can't make it any bigger because then the recording stops for some reason, so I will just have to leave it at that. I do apologize.
Created by a Big Bang. This Big Bang.
That is correct.
Sent masses hurling in all directions and eventually formed our.
And then it didn't hurl masses in all directions. First of all, the Big Bang kind of enveloped all directions, if you will. So the term direction doesn't really make all too much sense when talking about the early stages of the Big Bang. But what the Big Bang did is it hurled, if you would like to call it hurled, which I still find a bit meh, but it created all sorts of subatomic and later on then atomic structures. So most predominantly hydrogen atoms and some electrons. All fundamental particles were in there, certainly.
Our solar system. This, as you know, is NASA's layout of our solar system, where all 8 of these planets decided by chance to all rotate in the same counterclockwise pattern around the sun.
Now, there is quite a bit wrong here. So much, in fact, that I would like to talk briefly about planet formation and star formation, which is star formation actually is what I'm writing my master's thesis in right now, and by extension planet formation, because this happens in similar stages. First of all, when looking at star formation, right? He just said that all of those happen by chance. That's just wrong. This is not a statistical process. The way that stars form, and by extent the planets, because they form in the same processes. First of all, you have a cloud, then you have a gravitational collapse. During this collapse, a disk forms. This is known as a protostar. There are many different types of protostars. They sometimes are called young stellar objects. There are class 0, 1, 2, and 3 of those. And towards the end of the class 3, a star, a planet can form inside the disk. So what happens is that there is this disk, and this disk is rotating all in the same direction. And eventually, due to gravity, some of the objects are locally denser due to whatever. Can be chance, can be the influence of a foreign object, can be the influence of a shock wave from a neighboring star system or something similar. The density there locally increases. That means that this region then attracts more and more mass, and what happens at the end is that planets form. We have observational confirmation of this. Given to us by ALMA, the Atacama Large Millimeter Telescope. You can actually see it right here. This is one of the ALMA observations. In the middle here is very, very dense dust. Please keep in mind that ALMA doesn't observe dust. That doesn't observe the star itself. It observes the warm dust around it. So you have a star in the middle, and everything that you can see here is dust. And you can see here that some of this ring kind of is freed of dust. There is no dust here. There is no dust here. There is no dust here. There's no dust in this inside thing here. This is where we believe planets form, and these planets form out of a rotating disk, right? I would like you to keep that in mind. Stars form out of a rotating disk, and so do by extension the planets. All of these planets that we can see in our solar system have formed out of one of these disks. And as you recall from earlier when I said that this disk revolves as a whole thing. So the planets that evolve in there, that are created in this disk, are already rotating with the dust. This is not a statistical process. Very much not so. And I can't, like, why don't you just research these things before you say them? I am at a loss of words. Why? Why? You could have just looked up how we think that stars form and answer your own questions. You put zero efforts into making these videos, but then you claim that math alert could run Globies run when you don't even understand the first thing about what you're talking about. It's you're not putting any effort into this, and you can see that at every possible moment that you would see that.
The mathematical odds of this are 1 in 2 to the 8th power.
They were, if this was a randomly distributed constellation, which is not. There's a very physical reason for this. I could go with the same argumentation and say the chance that, I don't know, all of the photons that are coming out of my desk lamp at this moment going in the same direction are like 1 divided by 2 to the, I don't know how many photons are coming out of there, like billions, if even that. So I could do the same thing. It's just not something that can be or should be expressed in a probabilistic manner.
Or 1 in 256.
And if you express it in a probabilistic manner, because you have a huge sample of planets and their rotation directions relative to the original protoplanetary disk, then the chances would be extremely huge, like gigantic, that all of them orbit in the same direction.
Taking that into consideration, NASA also claims that our galaxy is made up of at least 200 billion stars, and they all rotate in the same direction.
First of all, they do not. There are some stars that rotate in another direction, predominantly towards the center. Not in every galaxy do the stars rotate in the same, in a similar orbit direction. This is a spiral galaxy, right? The Milky Way is supposed to be is thought to be a spiral galaxy with possibly some bars in there. In the very center, the stars will have a very, very strange orbit. Towards the edges, yes, most stars will rotate the same way. However, there are galaxies, for example, elliptical galaxies, where the stars can take on all sorts of weird-looking orbits. This is due to elliptical galaxies functioning fundamentally different from spiral galaxies, but I am spiraling a bit off the topic here. So let's continue with this, whatever this is.
Since there are 2 possible directions they could rotate in at least 200 billion stars, that means the odds of this happening are 1 in 2 to the 200 billionth power.
Once again, just as planets form out of a already rotating disk, it is believed, although this is a bit more complicated, I'm not an expert in galaxies and the development thereof, but as far as I know, galaxies form in a very similar way. That first of all, there's a huge accumulation of gas, and it eventually due to the collapse, it starts to rotate in the same direction. This is actually something that can be calculated for, and that we actually expect from both simulations and mathematics. By the way, maths alert, because apparently we can't do it, although I can very much tell you what's wrong and how we expect it to be like that, so,
The odds would be greater for you to win the lottery every day for the rest of your life and for the next 250 years.
If this was a probabilistic process, yes, but it's not. It's a physical process.
They also claim their satellites rotate around the Earth in these patterns here.
Not exclusively, but probably also in these patterns, yeah.
And gravity holds them in that orbit.
That is correct. Well, gravity and the velocity that they have, otherwise they would just fall down. The orbiting is the art of falling down but missing the Earth as you go.
If that were the case, that would mean our solar system and galaxy would have many more directions of rotation to choose from if gravity is the defining force.
Once again, if this was a probabilistic process, if all of these directions were set at random, I would agree, but they stem from a physical, somewhat well understood process,
making the odds of these claims being true even more impossible.
I just don't think you understand what odds are in these contexts. You can't approach every subject within physics or natural science in general with chance.
State that 8,261 satellites are rotating the Earth as of 2021 at 17,500 miles per hour each. This is a depiction of what that would look like, except there are only 6,000 satellites in this photo. Not to mention, NASA claims there are 23,000 pieces of debris the size of a softball.
You know that video is full of shit when it has more than one emoji in it. So everything in this video is so perfect that only a flat earthers can do so. The maths is completely wrong. They apply it without looking up anything about how we think it really works, making funny claims like inserting a whole bunch of emojis that, well, do they really have a right to be here? I don't know.
Softball
I love it.
And 500,000 pieces the size of a marble, rotating the Earth in all directions, also at 17,500 miles per hour. This would be impossible to prepare for or manage, especially since this is what 150 to 200 miles per hour is capable of.
You know, when I drove here today with the train was going about 120 kilometers per hour tops, I think. I don't know what that is in miles per hour, but somehow, right? I could sit in the train, just drink drink from my bottle and read something, and I didn't even feel a slight breeze. Well, why would that be? Maybe, just maybe, because I was moving with the train. Is that maybe possible? Like, I'm at a loss of words. First of all, the satellites that are moving at 17,000 miles per hour, whatever you just said. You know that they are orbiting in what is practically a vacuum, right? There is no air resistance. There is nothing there to hit them other than other satellites and micro meteorites. Now, these small meteorites hit them every now and then. This usually doesn't end bad. But there's so much space up there that two satellites colliding is extremely improbable. Sorry.
Imagine what 17,500 miles per hour would do, which is...
You know, on the Earth, this would make sense, but it's in orbit. I don't think you quite understand what orbits are.
Is also 22 times the speed of sound.
The speed of sound in air, I should mention.
Here's a bonus question. If you're spinning on the Earth at 1,000 miles per hour, while spinning around the Sun at 66,600 miles per hour, while chasing the Sun through space at 515,000...
We're not chasing the Sun, we're just moving with it.
...miles per hour, what do you think the mathematical odds would be that every single one of the meteor strikes on Earth would hit Earth at exactly a 90-degree angle?
First of all, how do you know that they hit Earth at a 90-degree angle? Now, I can already hear the flat earthers scream that, well, they are perfectly circular. That is because at a meteorite impact, there are such huge energies involved that the meteorite essentially turns into gas. It immediately, the solid becomes a gas. It kind of explodes all at once, and this leaves behind a usually very circular crater. With this said, not all of the craters on Earth are circular. There are some craters that came in at an angle, and I would need to look up that number. I'm doing this blind as per usual. I believe, like, unless you have a very shallow impact angle of like 15 degrees or below, you get a circular crater. And thinking about it, the 15 degrees is even a bit too much. It will probably be like less than 10, and that's very improbable because then the object has to go for a lot of atmosphere, making it less likely to actually hit the ground, and so on and so on.
Hit me up. You call me crazy.
I have not called you crazy once. I called you uninformed, by which I stand, and the fact that DC Force here has just uploaded this video from TikTok without changing anything is I love things like that. Even in this weird kind of square and square format. So yeah, maybe here's a tip. Maybe next time, before making all of these claims and trying to calculate something that isn't really a probabilistic process, maybe consider looking up how it actually works. And with that, I can see that my rambling has already brought us to close to 16 minutes. So with that, I will leave it. I thank you very much for watching. If you enjoyed this video, maybe consider leaving a like. If you enjoyed it a lot, maybe considering subscribing. And with that, I wish you a nice day, and I will see you in the next video. Goodbye!